Hey, ever thought you'd lose sanity? Because I've started to lose now since I've asked this one question. That a science, bro? And so, I guess join me on my journey here where we ask wonderful questions like what's in the menu? What do falling cats from high stories in World War II fighter jets have in common? And is cheating really good for kids? Well, we'll know the answers to these questions from the experts in the field as they provide us data driven solution, even when they are not aware that the guiding factor is in fact data. So join this wonderful geeky friend of yours in his journey as he asks just one question. That a science, bro? Hey everyone, this is the first episode of That Science, and we have a very special guest today. Right, for the first podcast, it was very generous of Venu Guntupalli to accept our request, and now he's here. He's known for his works in data science, at least in Stevens, one of the most decorated alumni out there. Venu has actually done a double master's. He started as an electronics and communication engineer, passing out from Osmania University in 2006. He then went to the University of Illinois Springfield in 2008, it says, and then he went to Stevens in 2015. He has done his job as all sorts of IT roles. You can find internet investigator, and he was a data mining analyst. That's where his analytics journey starts from, all the way to being a director at Jackson Hewitt Tax Service here now in New Jersey. Hey, Venu, thank you so much for being here. It's absolutely a privilege to have you on this podcast.
Hey, Saj. Thanks for the warm welcome and kind words. Excited to be here, and I haven't done a podcast before, so um, I'm also excited to have fun over the next hour or so.
Absolutely, sounds like a plan to me. Let's hope for an amazing session. So let's start with a very curious question coming here. Actually, I see a couple of master's degree on your LinkedIn profile. So what was the
Mhm.
inspiration behind having two separate degrees?
Right, good question, and a long story. So my first master's was in comp sci with a focus on security and networking side of things. As my career progressed, I was working more in terms of digital forensic analysis and anomaly detection and things of that nature, even though the meat of my job was still comp sci. That's when I got introduced to this whole area of data science or machine learning, I should say, and how anomaly detection was becoming more and more of an ML problem to solve than the conventional way it's been solved. I'm talking more from the perspective of antivirus suites that you have on your computer, how they usually worked only looking at signatures that have been fed to them, and how they fail when there's a 0 day attack, when they don't know that this pattern is actually a nefarious activity that they should catch it. So that was how I got introduced to the area of ML, and this was way back in early 2010s. And there wasn't much of data science or ML content out there like it is today. So part of it was being able to read a few books and also trying to attend talks. And Stevens is pretty close to where I live, and I knew that they started this program, BINA. So I started going there just to hear talks. There were these talks that they were doing on campus. And Ted very graciously didn't mind an outsider attending those talks. We had off-cuff conversations after a couple of those talks. It's just about what I did and how I found the talks interesting for my area. And slowly one thing led to another, and it seemed like I could really benefit from kind of getting a better sense of what this whole ML world is about. And we thought I could just start as a part-time student and at some point I decided it's not really totally fair for me to kind of dabble part-time study and work. So converted into full-time for a while, and then that's how the second master's panned out.
That's in fact a very interesting story. We hear a lot about how ML and data is changing the world, especially in the last 5 years. It's been the buzzword around. Uh, I think one very important question that stems out of it is, why is it used in every single business? We go to a few businesses that are related to finance. I think it's kind of obvious for the geeky ones to be doing the machine learning part, making impact with the finance industry. But now we literally see it everywhere. We see it in design thinking. We see it in making of menus when it comes to chefs and everyone. We do expect a few guests from very specialized industries to come in and talk about how the design thinking was inspired. Why do you think has this revolution come in about the last 5 7 years? Why not before that? Because it's been trending around for at least 5 years now.
Right, right. That's a very good question. So, as you know, this whole concept of ML existed for years, for decades now. I think a big part of why it's become so ubiquitous now is the compute side of things, how things have become much more accessible, and how we're able to do things at scale at a very efficient cost. So I think that kickstarted a wide range of adoption. Obviously it didn't trickle down to individuals, just end users who don't have access to these high performance compute. But I think with the advent of cloud and how just any individual can spin up a cloud instance and just try a whole bunch of complicated algorithms, that whole enablement, I think, is what actually kickstarted this ML application and interest in ML. Ultimately, for me, ML or data science, it's all about trying to structure your ideas and trying to identify um, i- if else logics and rules from a whole bunch of different possibilities that would be really tricky for an individual to kind of figure out on their own. So I think it plays a big part in most things that we do, right? Because in everything that you do, it's really important for you to kind of figure out what are the more important things compared to all the things that are available, which is, so to say, keep the noise aside and pick the ones that are really pertinent for you. So there's definitely going to be a wide range of application of ML and data science. And there's another level of ML that serves in specialized areas. To give you an example, I'm thinking about conversational AI, like what Alexa does today, or self-driving cars. So those are what I call as level 2 applications of ML. They're very specific, and they involve much more research and much more complicated systems and rules underneath. So every area, I think, could benefit, to answer your question, but by how much and what it takes to get benefit out of certain things, it's all dependent on industry, I would say.
Oh, thank you. Yeah, I think that's actually a very sort of perfect, a very wholesome explanation, and it also falls in line with something that I think. So, at a very personal level, the data science was a very empowering to me personally, because I thought of getting answers to a few questions that I wouldn't have otherwise. You can Google about everything, but you don't have a data backup for it. So things are very intuitive until you have the numbers coming into play, and then you finally have some pure deductions to make. And I think that was one of the greatest inspirers for me to join the field of data science and pursue a master's in business intelligence at Stevens. I started with a
Nice.
few books of Stephen and Levitt, the freakonomics series, and then also a few
Hmm.
from Malcolm Gladwell, and the count never stopped. It just progressed from there on. But I think back then I was a lot more fresher in the field, and now I think I have a couple of years of experience, at least educationally. Looking at your experience, I think it's huge, and it's way more than possibly my experience. So, how do you think has your perspective and take on data and data science in general changed over the years?
Right. Um, so I still remember in the beginning, it was all about trying to just chase after a metric or two. You're trying to look for these amazing algorithms that could improve whatever is your ultimate metric that you're trying to optimize for. An example could be F1 score, or balanced accuracy, things like that. So most of your time was spent around that, at least for me in the beginning, when I got introduced to ML and I started doing ML hands-on. But eventually it comes to you that it's more about practicality of deploying your solution and how what you're doing translates to business impact. So the biggest change, I would say, the way I practice ML today versus how it all started would be trying to get this perspective of how your work is actually translating to something the business can actually use versus you trying to do a stellar job of building a model that's excellent across a bunch of metrics that are non-business related. So that I think if you were to ask me what changed, that would be the biggest thing, I think. And the other thing is how you're focused around reproducibility and trying to bring in efficiency around the things that you do. As an individual, probably you don't really care about those things, but when you're leading teams or when you're collaborating with others and you kind of have to hand off at some point and move on to other things, it becomes really important that whoever you hand it off to are able to pick it up and kind of get a good understanding of what's been done and what needs to be done. So the way you design your solutions, trying to keep it as much in terms of modular design, as much as modular as possible, trying to do a good job of documenting your things, trying to kind of bring in the standard DevOps culture. All those things, I think, have now become a de facto part of any model development work that I do, or rather any data science project that I do. So those things, I would say, are what kind of tend to stick out and stand out to be much different than what I used to do when it all started.
Oh, sure. I think that's really insightful. I think the fact that you have to ask the right questions and the fact that you have to not limit yourself to the exact question that you ask is amazing to know. I think now that we are talking about data science in general, and I am talking about the new graduates who will be coming in, it's been a year and a half studying at Stevens, and it's been a wonderful experience. But a lot of people have this dilemma of actually taking data science or just doing it for something they like. What would be your suggestion to those people? How can those people really decide on should they actually pursue data science, or is it just good as a hobby to them?
Right. I think there are a lot of things that come into play there, right? I think the most important thing from the perspective of an individual is what is their end goal? If it's all about being in a profession that's related to data science, sure, there's a lot of content out there, but I think degrees do add value. There's more structured way of pedagogy there. And there's no doubt value that a good institute like Stevens, as an example, can bring because of its alumni, because of its location, because of the very good rate of folks finding jobs once you graduate and all those things. So it entirely depends on your goal. If you're looking for a change of career, or if you want to just kind of get better at what you're doing. Depending on that, you kind of get to decide what level of engagement you want to have with data science. If you're genuinely thinking about improving your data science chops and just using that knowledge in whatever other field that you want to pursue. For example, meteorology, right? You do your standard things, and data science can obviously help you do it much better if you're in the area of forecasting and all those things. Maybe you don't have to kind of take an entire program, a 2-year program or a 1-year program. Maybe you could just start dabbling into it as a hobby and kind of do some of these online things. And then depending on if you want to still stick to meteorology, or if you want to just use data science as general in any industry, then that's when you kind of decide, is it worth jumping into this institutional programs of 2 years or a year. On the other side, if you do want to get into hardcore ML side of things, then I think what's available out there is very good. These days, there's a lot of high quality content, but the same age-old problem persists, right? There are first of all, the right structure in terms of journey of learning is not really obvious. There's so many options out there, so much noise, as I would like to call it. And then understanding what actually happens in the industry to kind of benchmark yourself to say, okay, this is what I've learned, this is how it's done at level 1 expertise, this is how it's done at level 2 expertise. All those things come into play when you're part of a close-knit network. And I think those sort of things come again with certain programs and certain courses that you're part of at major institutes. So long story short, to answer your question, I think it all depends on where you want to end up being. What do you foresee yourself doing in a year or two from now? And then depending on that, you kind of decide on the level of engagement that you have. But either way, I think the biggest advantage of dabbling in data science and ML, at least from my perspective, I'll tell you, is you end up being a bit more analytical than when you started. It also translates to your personal life, not just related to work, on how you think about things and how you approach any decision making.
Right. I think that's really interesting. I think one important thing that you bring up is the noise that I think everyone should be wary of, but it will persist nonetheless, because if people start walking in different direction, there will be a lot of trails, and I think the same stands true for the field of data science as well. So, do you think there is a certain path that one can follow, or should it be completely random and then you eventually know with time what path is right for you? Because just to solve one problem, I think there we have a million possible solutions in the field of data science. How do we think about those trade-off? How do we think about where to start for ourselves?
Right. So I'm guessing you mean for someone who's not in the data science area yet.
Yeah, someone who's just starting, where do you think would be the right place for him to start?
Okay. Okay. So you might have heard me say this during one of my boot camps. I asked folks, a raise of hands, how many of them use SQL. And yeah, just to make it a lighthearted conversation, I say, I wouldn't be offended if you get up and want to go out and take this time to learn SQL. So that's how much I value SQL. Um, One, it's one of those languages that's been used for, I don't know, probably for decades now. Never goes out of vogue. It's always there. And I don't see any reason why SQL wouldn't have a bright future, at least for the next decade or two. Um, and the beauty of SQL is it also forces you to think in certain way when you're working with data. Um, it's not as let me put it this way, it's not as flexible as let's say Python, the way you can manipulate things and the way you can write code. There are very restrictive ways of doing things. And A, it makes you be a good programmer, that's for sure. B, it also gets you into the mode of really thinking about data differently. Um, so an example is when you're working with time series data, it's very different than when you work with kind of data dump snapshots. Um, you're thinking about a whole bunch of different things when you're trying to calculate an average. You're thinking about a whole bunch of different things when you're using SQL versus typical scripting language of sorts, if I may say. And SQL is still the choice of language to access big data sets. So I would strongly suggest that as a good starting point. I also tell people that you start with this, and if for whatever reason you decide you don't want to pursue this career in data science, at least you're left with strong SQL skills, and that opens up a whole new job opportunities for you. So SQL, yeah, SQL is number one for me. And then after that, I would strongly encourage folks to think about statistics, the good old stuff that you probably learned in your undergrad or in your high school about likelihoods, about statistics like maximum likelihood estimation, things like probability distributions, all the basic 101s. I think those are good refreshers, and you will appreciate better the initial few algorithms that you tend to learn in this area when you decide to dive in. And once you're through those, and once you're introduced to the ML side of things, extension of statistics, right? ML is nothing more than just kind of like extension of statistics at scale and peppering in a few more algorithms. And that's when you'll also kind of appreciate coding differently for big data, versus working off of very little data that probably fits on the RAM of your computer. So you evolve as a programmer, and then you're thinking about, okay, I have all these things. I don't want to repeat all these things. How can I orchestrate these things to run for any project that I'm working on? Then you're thinking about DevOps. Then you're thinking about scaling it. So that's where cloud comes in. So it's a nice layered approach, if you ask me. Starting with SQL, then statistics, then working with a few ML and data manipulation packages on your local, and then thinking about bringing in cloud aspect of it. So that is something that I would recommend as a possible path to think about. Obviously, you can bring in different things at different point in time, depending on what you want to do or depending on the time that you have. But this in general, I think, has worked well for folks I've mentored and continue to mentor. And also in my personal life, I think this has served me well.
Right, I think that's actually very well structured. I wish we had met 4 years back, and then I would have probably known a lot more about what approach to take. Looking back, I think this would have been much, much more efficient. But I think one another question that I, as a fresher, had back 2 years back was that why do we use languages like Python make things heavy and complicated for ourselves for a few regression models that can also be run on Excel? So I think this is also something that people have a lot in common. They don't know at what point should we start switching from Excel and move towards a higher sort of program, and what are the trade-offs between different languages. So do you think that
Yeah.
comes as well with the experience, or is it more of a straightforward answer or a straightforward approach to that as well?
I gotta say, this question popped up in my head many times when I started. When I was at Stevens, the good thing about Stevens is they spoil you with so many tools. I'm sorry if my voice is a bit unusual here. It's pretty chilly, so I'm shivering when I'm talking. Um, so the good thing about Stevens was there are so many tools there. That was a good thing and also a bad thing because you didn't know which one you want to stick with. And you had very little time to kind of decide because when you're applying for jobs and there's a career that you're thinking about, the choice of tools actually are really important. As an example, let's say if you didn't want to pick R or Python and if you wanted to pick SPSS or SAS, that's a completely different set of jobs that you could apply to if you don't pick up any of the programming languages, right? If it's just SAS and SPSS, it's a different world. Um, Versus picking up one of those programming languages. And then that opens a whole bunch of different job opportunities for you. So I think that does play a big part. If changing careers is one of the intentions of your journey of pursuing ML or data science degree. Um, I think Excel is a great tool. It's just that at least back in the day, Excel wasn't built for doing things at scale. That's one. And Excel isn't a great tool when it comes to being a cog in a wheel, meaning if you rely on certain formulae or statistical approaches with Excel, it may not be the best tool to make it as a part of your end-to-end pipeline when your other components are programmatic. Yes, you could go crazy, write macros and do all those things, but it's not built for that, right? Um, so yeah, so with all those constraints, I think ultimately it'll come to you what is the best thing that you want to pick and just kind of go run with it. For me, I've been a programmer for most of my life, so Python and R were definitely two things that I wanted to pursue. And I think very early on, I made a decision that I'm going to stick to Python. Nothing against R. I love R. I don't get to practice much, but um, back then, I think my decision making points were, Python is a bit more generic. It has a lot more hooks and levers that you could use to kind of tie it to other components. If you wanted to make a web app, or if you wanted to kind of bring in things related to scraping, and it's a bit more of a general purpose tool, like a Swiss Army knife, if I may say. Now, R has evolved since then to also do a lot of those things. But at least back in the day, it made sense for me to kind of use Python. No regrets. I still love R. And actually, I'm envious of a lot of things that R does so well, especially on biostatistics side and their Markdown. I love R's Markdown. I wish Python has something like that. And visualization, right? Python is still all over the place. There is no one proper framework that everyone is back in. For a while, it was Bokeh. Then it was, there was Plotly. There was Dash. Now there is Streamlit. There's always, it's always been a fragmented space for Python, whereas for R, a lot of folks have been kind of behind ggplot and the future versions of ggplot that have come out since it started. So a lot of pluses and minuses, but again, if you kind of look at all those, for me at least, Python was a trade-off that I was willing to take just because of how general purpose tool it is and how it kind of blends well in terms of APIs with a lot of other cloud providers as well when you want to tap into those components.
Right, I think the way you say that it's a Swiss Army knife is actually, in fact, very interesting. You can use the APIs, you can have all sorts of data to be analyzed, and then you can come out with some wonderful outcomes. So I think that is exactly something that I, and my experience, as much as I have, falls in line that Python is this huge chunk wherein you can do probably endless things. And R is just really good with what it does. So I think I definitely fall in line with your thoughts here. And what also falls in line is that I started my career as an electronics and telecommunication engineer as well, just like you did. And I see a lot of your experience comes from Altis, which is a communication based company.
Mm-hmm.
And that was 4.5 years of wonderful experience. Would you want to share something about being there, what kind of challenges you faced there, and what was the most exciting part about being there?
Yeah, Altis was great actually. I think Altis only happened because of Stevens. Stevens has these great talks that they do. I forget exactly which series it was, but there were a couple of guys from Altis who were there. Ben Tada, who was back in the day president of Cablevision Media Sales. Altis was Cablevision back in the day. Um, and Paul Haddad, who was, I think, VP at the time in media sales. So they were, and I think Ben Tara is, yeah, he still is part of the advisory board at Stevens. Get to meet him once in a while. So they were doing a talk about how Cablevision had this tool that kind of does targeted advertising, also known as addressable advertising on TV. And, and I think I just came to the school that day a bit early because I was still working while I was, the first couple of semesters while I was in school. But for whatever reason, I came in early to school that day, and I just walked into this room where this talk was happening. And someone who's thinking about making a switch to data science as a career, I was just blown away by the amount of data that they were collecting. I didn't know until then what amount of data a cable TV company can collect. Well, I say it's a cable TV company, but that's only a part of what Altice does, right? It's cable TV, it's internet. Now they're also in the mobile space. Then there is also phone, landline-based phone. So many things that Altice does from telecom and a mobility perspective. But just understanding the amount of data that you could get off of these things, your set-top boxes and routers, I just didn't think about it until that point, until the presentation. For me, a cable company was just a company that manages pipes until that point, probably satellites, nothing more than that. The naive me thought a cable company was all that. So knowing that every interaction with your remote, every click on any website that you visit, and how all these things can be captured, and how the data is so rich that you can kind of model behavioral analysis off of that, and a whole bunch of things that talk opened my eyes to. It was just mind blowing for me. So I think it was a 60-minute talk, and it was done, and my class started. But I luckily, I think it was David Belange's class, I think, after the talk. So I just told him, pardon me, I'm going to be late for the class. So what I did was just walked up to Ben Tada and Paul Haddad and told them, I want to work for you guys, and just tell me how to make that happen. I think they introduced me to the HR. She was also there that day. And she said, this is what we do. We have these intern programs. You can think about applying for those, what have you. Interning wasn't my idea back then, because I already worked for a long time. I didn't really think about interning as an option, but I really badly wanted to get my hands on the data set. It was just unbelievable what I learned from that talk. So one thing led to another, whole bunch of hounding and emails later. I did decide, joining one of their intern programs was the fastest and easiest way to get into Cablevision, which I did. And from there on, just one thing led to another, and decided to take a full-time job there, and been there for almost 4.5 years. Good times.
Absolutely. I think it's so wonderful that you actually went there and say, "Hey, I really want to work for this company. How do you make that happen?" I think that requires some level of dedication, and that was wonderful to hear about how you got into the company. I think one of the key challenges when you work with a company that's based in communications and actually knowing things is the legality issues with the thing. So if you collect data, there's a lot of gray area as to where you have to stop, what data is safe to collect and which one is not. So did you ever have a chance to have discussions about that, and how do you make those trade-offs?
Yeah. So going in, data science was, I wouldn't say new at Cablevision, but it was relatively new for most people. So I think we were all learning as we started taking on more projects, what's good, what's not in terms of data to use, what's legal, what's gray area. So a very good thing that we did, thanks to my boss, she was brilliant. She had the foresight to think about all these, is engaging legal folks very early on to say, this is what we're looking at, and this is what is part of the end product. When I say end product, the ultimate equation, the decision making equation that comes out of the model. And do you think from legal perspective this is okay? So by making legal folks part of the stakeholder committee, I think the learnings were quick and the learnings were great. So the first few projects were a bit challenging because you're used to kind of getting access to everything and using everything, made your life easy, but now you have to go through this additional hoop of getting approved from legal and compliance perspective. So as a programmer, as a data scientist, sometimes it was frustrating. You didn't really appreciate all the hoops that you had to jump through. But I think over time, I've begun to kind of appreciate that. I'm actually grateful for going through that experience, because now you start thinking about that from the get-go when you're actually talking about a project that you want to work on. Now you're hardwired to also think from the perspective of legal and compliance folks and structure your solution or structure your pipeline accordingly, rather than kind of dumping everything and in the end someone kind of giving you a slap on your wrist because of including things that you're not supposed to include, and then kind of redoing the whole thing again because you're probably losing a whole bunch of predictive power or what have you if you included those. So it was great from that perspective. I do have people I hired and junior data scientists who still express frustration at that. But I think with time you kind of appreciate that you have to have those things in place. it's not only fair for the company, but it's also a good thing for the end user when you actually resolve all the things beforehand and not kind of negatively penalizing a certain segment of people or product.
Oh, that's actually very amazing. The fact that you learn so much more about legality and you grow overall as a person in terms of business when you come into this field of data science, because what you're essentially doing is contributing to the business. You're giving them new insights, giving them solutions to optimize a few things here and there. So I think that not only gives you an idea about your own field, but makes you much more knowledgeable about the field of business in itself. I think I'm speaking more in perspective of data evangelist, because I personally believe that the world of data science is amazing and it's cool. And I think we now move on to this amazing section where I talk about how data science is so amazing, and we talk about a few stories and few coming out from your teachings, few coming out from other places that I've gathered. And I'm hoping to have a few questions thrown at you, and I'll hope for you to answer those questions and make everyone interested in the field of data science. Sounds like a plan?
All right.
Right. So the first one is this is definitely coming from one of your speeches, something that opened my eyes, something that made me very interested towards the whole part of statistics and knowing my stats a lot more. And this is something that, to give you a clue, that has something to do with the F1 scores, that really wanted me to admire the beauty of F1 scores and what they bring to the world of statistics. There was a cancer research, and they had created a wonderful machine that predicted with a 99.9% accuracy if a person actually had cancer or not. Uh, and then they took it to a design company. They said, you can probably implement this in hospitals. This is a wonderful machine that we came up with. And that machine was thrown out of the building. Why do you think that happened?
Okay. I think I remember that. It's probably because of unbalanced data and how it was probably just classifying everyone as one class or the other and was still showing fantastic accuracies.
Right, that's absolutely true. I mean, you had to know this. This comes out from one of your most inspirational speeches about Python and why data and analytics play such a crucial role. Why you need to know that what you've come up with can probably not be that great of a masterpiece if you really look at from the right perspective. So, for the viewers who don't know and are really relatively new to this, well, out of 1,000 people, probably one or two people have cancer, which is a very good thing, which is we are very lucky to have that sort of an imbalance and to know that most people are healthy. But that's the fact that only one or two people out of 1,000 will have cancer. So even if you predict that no one actually had cancer, and if you predict no one correctly, the people who had cancer, and if you all the time say that, oh, you don't have cancer, you'll still be right 99.9% of the times. So that's a very interesting stat to have about. I'll pitch you a new question, and I don't think this is coming from one of your teachings or lectures, but this is rather coming from one of the most basic math questions. There's a small pond, and in this pond we have 200 marbles. Now, out of these 200 marbles, 198 are colored red and two are colored blue. So clearly the ratio is 99 to 1. So 99% of the marbles are red. If I want to convert this ratio to 98 by only removing marbles and not adding anything, how many red marbles do you think will I have to remove?
Good question. It's been a while since I saw probability, but probably half of those red ones.
Right. And it's super counterintuitive, because when you want to bring in 1% of that change, you generally think that you can remove two or three and then you'll be done. But you're really halving the number. So from 200, you're just taking it down to 100 and removing 100 red marbles. So I think that's one of the ways I really intend to convert people, by telling them that, hey, things can be a lot more interesting and lot less mundane and banal in comparison to what we've already learned, because that's what data throws at you. There are several complications that come in at various points of time, and I think one such complication that I remember comes from the British Air Force. And these people at the time of World War II, they thought, the planes that came back, let's do a gunshot analysis on these planes. I'm sure that you've heard about this one too. I think it'll be amazing if you can explain this
Mhm.
example about the idea and how data can be really misleading to everyone who's listening to our podcast.
Right. If memory serves me right, correct me if I don't get it all right. Did you say British? I don't remember that part, but it was about looking at planes, probably World War One or two, and seeing where the gunshots were on those planes, where the planes, got all these holes through these gunshots, and trying to figure out what's the area of the plane that needs to be probably made a bit more robust or stronger to survive. And I think the conclusions, I don't exactly remember the takeaways, but the conclusions I think were false because they only looked at planes that survived. Actually, if you also looked at planes that went down, in determining what parts of the plane need to be strengthened or what part of the planes are good enough to survive, it would have made more sense. But just by looking at planes that made it back, I think they drew wrong inferences. Is that the example you were going for?
Absolutely. I think that was correctly picked by you. Amazing. So, I think this is something called selection bias, which is one of the greatest problems in data science. You don't have to have a bias, and you really have to know what data you are working for, because the planes that came back, there is no point in reinforcing the steel because they will come back anyway, because the parts that are damaged are not the crucial ones. So, I think that was one of the greatest takeaways. There was a Hungarian born mathematician called Abraham Wald. Salutes to you, sir, for bringing out this wonderful logical fallacy that people generally fall for. And there's also a very similar fallacy that people actually fell for about cats. And this is a wonderful one. They thought that the cats, when they fall from over 6 floors, they are less hurt than when they fall from 6 floors. So I think this was very weird. I mean, this is a gory thing to imagine, cats falling down, and this is really not a pleasant point, but this is what people actually thought, that the cats who
Mm.
fall from more than 6 floors are likely to have less wounds than the one that fall from 6 floors. And they thought it has something to do with the terminal velocity and some amazing physics, which was really debunked by a lot of doctors, saying that, hey, the ones who fall from over 6 floors don't even survive to make it to the hospital. So I
Mm.
there's this wonderful thing about statistics and the way that you have to know what your data is. Uh, any
R-
thoughts on that, Venu?
right, right. So I think social sciences has done a great job on educating people. Statistical work in that area has done a great job of kind of uh, educating people on the right way to collect data, the right set of questions to ask, and the right way to design experiments. It's really critical because even if you have the right data, if you don't properly assess how your intervention is panning out, the classic A/B testing or ANOVAs or a whole bunch of other things that you could think about, you're not really sure if your intervention is actually helping or not. On that note, actually, the FDA paper that they released recently on their rationale for backing the what is it, the Biogen product is so fascinating. I'm only halfway through that paper. They do a great job of kind of giving you the math behind why they think it's a safe drug, even if the trials were done on such a small scale compared to all previous vaccinations, which had much bigger numbers during trials. So a lot of these things at very different stages are so critical to kind of conclusively say your final finding is actually applicable or not. All the way from how you're collecting data, all the way from how you're designing your experiment and the hypothesis that you want to validate with the data that you collect, and the kind of things that you're using to say if your intervention was effective or not effective. Very, very important in this day and age. Sometimes you're blessed with having data that's very clean and is taken care of in terms of balance or bias or all those things. And sometimes it's on you as a data scientist to kind of figure out what's iffy, what needs to be corrected for. A lot of those things will come with time and experience. So it's really important to kind of expose yourself to different data sets, of good quality, bad quality, and kind of look through literature to understand what people have done historically where there were issues with data and how to correct for those. Um, so, yeah, that's where I think, again, going back to my earlier point about SQL, a whole bunch of things that you will discover by being analytical and being able to play around with data. And hopefully by then, when you have your statistical hat as well, you're able to kind of determine the effectiveness or the strength of certain data points versus the other in trying to answer the question that you've posed to yourself as the end outcome of whatever project that you're working on.
Right. So I think that's really something that makes me visualize all of that. The terms that you use, the statistical hat, using Python as the Swiss knife, probably using SQL as the right finder, you can become the right Sherlock Holmes and find who the actual criminal was. I think where I really fall in line absolutely with you is the fact that data can really lie to you sometimes, right? There are so many matrix to know what mistakes you made, and sometimes you can just end up creating a masterpiece even when you think that it's not that great. About the paper that you mentioned, which I certainly will now have to go through, I think those are a few amazing insights. How do you think, Venu, in the coming years, is data science going to play its part in almost everything that we see? Because it's estimated by a lot of people that data science will grow much more than what it already is in volumes, because it has now become that essential key in finding out what the society really needs and what the business in general might really need, for that matter.
Yeah, um, that is true. I agree with that. I think we only scratched the surface in terms of how data science and ML can be infused with just about everything that we do today. I do think that a lot of specialized branches are going to evolve out of this one umbrella data science industry, more so from ML perspective. I see a future where ML is commoditized. We're already there. By that, I actually mean solutions that are available out of box, and for you not to worry about the model or the algorithm that actually drives it. An example would be, things that you could find on GCP or AWS for AI solutions like, interpreting text, identifying text, or chatbots right out of the box, or forecasting tools. You just throw in your data and it forecasts for you. I think AWS was the first one to also assign a probabilistic score on those forecasts. So I think there are these ubiquitous use cases that are applicable for a lot of different industries and companies. And for those kind of situations, I think we are evolving to a stage where we just kind of tap into a product, an API, so to say, and kind of generate the results. You don't have to worry about the upkeep of it, don't have to worry about what actually goes into determining the predicted number. Um, and those sort of things, I think it'll be more and more challenging for individuals and smaller entities to kind of build on their own, because data is the king in those cases. And who better than Amazon or Google or Microsoft of the world in terms of pulling together data and training their algorithms to work off of those. So yeah, and I think big deal of these applications are going to be commoditized. So that's one. And the other one is, in general, using data science to improve your product or processes or decision making. Right. That also shows in your BI tools of late, right? If I'm not mistaken, Tableau, Alteryx, and QuickSight, and all these tools are slowly introducing simple ML tools. Sometimes it could be as simple as polynomial regression or linear regression, I think, but they're bringing in these elements of quote unquote predicting or forecasting things, where you not only look at the current state of data, but you're also trying to get a sense of what would it look like, whatever your grade is that you want to project over, and then drive certain decisions based off of that. So for me, data science, I think the biggest value is going to be in helping make these decisions for most generic use cases, not necessarily in use cases as profound as self-driving or cancer research or those sort of things. Those will evolve, but those will evolve only in the hands of some specialized players. But when we're talking about the biggest reach, I think a lot more folks are just going to benefit out of how decision-making perspective of ML and data science is going to just improve their day-to-day decision-making and their product, depending on how you integrate those capabilities into your pipelines.
Right. I think you rightly touched upon how there are lots and lots of sources of data, and there are lots and lots of ways that you can get data in. I think one of the most richest sources of data is the text-based data nowadays. And we see a lot of people, it serves to businesses like you just have a person who takes the survey and comes back and yells at you and says, hey, you made that thing bad and you really need to improve that for people to really buy your products. I think that is one way that text-based data has been changing the world. But we see there are petabytes and petabytes of text-based data collected from Twitter, from Facebook, from other social media that actually bring an impact in the way things are designed for companies and the way the new startups come up. How important do you think is this revolution of text-based data in the history of data science and in the history of business in general?
Yeah, very important, right? I every once in a while kind of appreciate the age that we're living in and how powerful the NLP tools are, that are out there that make your life so easy these days. Um, I think it's very important, right? Because anything that you do today in terms of product, it's the data volume that you have to think about is huge. It's very rare that you're working in a space where you don't concern yourself with the volume of data. Maybe there are areas, but more or less, a lot of the new startups would have to think about that the volume of data that they want to work with. NLP, thankfully, it's such a mature topic relatively compared to where it was 5 years ago. Um, is a great thing to take advantage of, right? Because again, going back to my earlier point about how things are commoditized, a lot of those commoditized tools are around NLP as well. Um, these major cloud vendors definitely have them. You can have these topic extraction models that can be just called by an API now. You obviously have to train it slightly to work for your set of corpus, um, and you probably also have to define your objectives. But other than that, I think the heavy lifting is all done by these really complex algorithms that have been trained on tons and tons of data behind the scenes. It's only fair for you to take advantage of that if you're thinking about evolving a product. And I think where I've seen a lot of folks fail is not knowing about these things. In fact, they actually embrace these things. It's just that they don't include this as a part of their development pipeline in such a way that it's easy to always go through this process iteratively. It's not the case, unfortunately. A lot of times what I've seen is this is done in isolation as a one-time thing. So that's where I think if you start kind of thinking from long-term perspective and making this a part of your development cycle to make sure this is always a process that you go through and design your flows in such a way, then I think you can always take advantage of this to enhance your product or your client experience or whatever your objective is.
Right. I think that is tremendously informative about how NLP is bringing about that change and where NLP stands today, and that the fact that it's a little underappreciated in comparison to what it should be. It's a little underhyped in certain ways. I also have this one very, very common question coming from people about how do we make these trade offs, right? Coming from, again, a fresher point of view, the viewers who are watching and who really are interested in the field of data science and who probably want to enter, they're often confused about all these heavy algorithms. Not a lot of institutions, not a lot of companies are opening their arms wide open for these heavy sort of algorithms that rely on a probably graphic card, some deep learning models, and they heavily rely on what's the basic analysis, probably an EDA or some sort of regression models that are not very heavy. So the technology is advancing at a rapid pace, but the applications are still a few years away, it seems. So, what do you think would be an ideal step for a person to learn? Should he be more focused about learning what's already there and improving on that so that he gets a job instantly, or should he focus more about the niche?
Yeah, that's a very good question. And I think I tried to address that during one of my sessions. I used to do a session during, I forgot what exactly it's called, but it's basically about welcoming students. And I used to kind of spend 30 minutes on trying to help students out to kind of structure their learning path and not getting themselves overwhelmed. And part of the process is I exactly address this question. So so coming in, it's overwhelming, right? All these things that you mentioned, especially in this area in data science, there is so much coming up every day. So much coming up every day. The funny thing is, the Python versus R debate still persists. So not only do you have to make the decision, but you also have to think about all these new things that are thrown your way every day. Your birds, your GANs, and all these things that evolve day after day. Um, so I really liked, I forgot who I heard this from first, but I really liked the approach of T versus I in terms of how you want to be. I think I is where you kind of get yourself familiar with a whole bunch of topics, but then you pick one area that you want to really deep dive into and become sort of an expert in, relatively speaking. So I like that approach. But even with that approach, I'm talking about purely from the perspective of being good at what you're doing and landing a job at the same time and not kind of going crazy trying to be good at everything. And at the same time, you also want to get some help in trying to understand what are these things that you want to familiarize yourself with, and what is this one thing that you really want to be good at. So in looking at the landscape at this point, I think you definitely have to be a good programmer, um, definitely a good SQL programmer, and then Python or R, whatever suits your needs. Um, but I'd also strongly encourage DevOps and cloud side of things. When I say DevOps, it's mostly around your Git, or trying to be able to orchestrate a pipeline rather than just running one code to run a model. Think about how you can have a bunch of things coming together to handle data processing, model building, training, validation, and serving, and trying to do all of that on cloud. Pick whatever cloud vendor suits your needs, GCP or AWS or Azure. I'm personally biased towards AWS and GCP because a bunch of evaluations that we did, for whatever reason, I always like these two better than Azure. I could be wrong. Now maybe Azure is much better. I don't know, but pick one of these cloud vendors and just try to emulate whatever you do on your local on cloud. So I think that covers enough things to be attractable to a whole bunch of companies, and you're casting yourself a wide net in terms of being a prospective candidate. And then you kind of focus on one thing that you really want to be good at. It could be NLP, it could be object detection, or it could be autonomous driving side of things. Any one area that you want to pick on and really be good at. So I think this approach kind of helps you get a job first, if you ask me. And then, depending on how it goes at your job or how your interests evolve, you can kind of hone in on one area and be really good at it. But this is typically what I tell folks. Think about doing these things, about doing things on your local first, and then scale it up.
Right. Thank you so much. I think this entire session has been wonderfully insightful, and I've always known you for the fact that you believe in giving back, and you've come to Stevens a variety of a various number of times, and you've been here too. Thank you so much for throwing light on some of the most untouched topic in data science, and at least from a professor's point of view, I think there was a lot that I could gather out of this. Thank you so much for being here, Venu. We surely look forward to have you multiple times on this podcast when we talk about a few niche topics, when we get into the nitty gritties of data science, when we start series with stats. I think your experience and the way you deliver things has always been wonderful. Before you go, I just want to appreciate you not only for this, but also for a small Python session that you had. And I would really want to admire your impeccable sense in the way that you can deliver an entire language and a lot of its knowledge in merely a day. So I think that's definitely commendable. Thank you so much, Venu, for joining today.
Oh, very, very kind of you. I had fun, and looking forward to doing more of these. And just a quick note on the boot camps. I do think a day is not enough. Hopefully, I can tend to convince to kind of make it basic and advanced, split it into two courses. So hopefully that's going to pan out over the coming semesters as well.
Sure. And Professor Storr, if you're hearing this out, we surely need more of Venu sessions. And I would definitely approve of that. I would definitely stand by that. Great. Thank you so much for being here, Venu.
My pleasure. Have a good one. Thanks for having me on board.